Hey, hopefully this video finds you in good spirits, not too frustrated with the e-learning that we're been thrust in so far. But today we're going to talk about factoring. This is a very important topic that you're going to use a lot throughout your high school career in mathematics. So it's important that we work hard on this one and we get it done. All right, last time we talked about a GCF. So those first few examples is what we've been doing so far because you're going to have to use it again. So remember, if I'm looking for the GCF in example A, I need to list out all the factors of x squared. Well, the factors of x squared is x times x. Then I also need to list out the factors of x. Well, only factors of x is x and 1. Then I want to take out the GCF, which is the greatest common factor. If you look at these two, the thing they have in common the most is just 1x. So therefore, I know my GCF is the thing that they have in common the most, which is going to be that 1x. So therefore, my GCF is x. Now, my final expression is going to be the GCF times whatever factors are left. The only thing left here is an x. The only thing left here is a 1 because we took these two things out. So what's left inside the parentheses is x plus 1. Now, I'm not going to go through all those examples because I don't want this video to be too long because we worked, before break and all of last week on that stuff. So you guys are good to go with that for the most part. So we're just going to keep pushing and look at the actual factoring of a quadratic, which is what we're going to be doing this week. So here are your steps to do so. You should have this document on Canvas, and there goes the steps. Every trinomial that we're going to work with this week is going to be in this form. It's going to be of x squared. It's going to be ax squared plus bx plus c. A, b, and c are numbers. A cannot be 0, or else it's not a quadratic. And there's no reason for us to do this. So A, B, and C are just numbers. Okay? So, with that being said, let's go through and let's go ahead and let's look at our example here. First thing you want to do is you want to list A, B, and C. A is always going to be this number in front of x squared. B is always the number in front of x. C is always the number that doesn't have a variable with it. So, let's go ahead and look. Okay, we use something called the box method. All right, so step 1 says go ahead and list A, B, and C. Well, my A, if there's not a number in front of there, we can put that imaginary 1. So my A is 1, my B is 7, and then my C is 6. We also want to go ahead and multiply A times C because we're going to use that up here, CA. Okay, so we'll call that CA instead. Okay, so there's two things we're going to use when we factor. We're going to use this right here, which is called a CAB table, and we're also going to use this box over here. Okay, those are the two things that we're going to use to get our factor, and then we'll get our answer. So what I need to do now is I need to multiply A times C. If I do 1 times 6, my C times A is 6. So I'm going to put that there. I need to list the factors of 6 that are going to add up to be B. My B is 7, so they need to add up to equal 7. So now I'm going to list my factors of 6. I know 1 and 6 are factors, and I know 2 and 3 are factors. Which one of those factors are going to add up to equal 7? Well, 6 plus 1 is going to equal 7. So those are the factors. Now, when we enter into this box, we're going to take these factors and put them in the box. When we put things into the box, it's always going to be ax squared here. You're going to use your factors here. And then factor. And then your C is always going to be there. Okay? Whatever factors you pick are going to go here, and they're going to go there with an X. And then your C is going to go here, and AX squared is going to go there. So ax squared for us is going to be 1x squared here. Then you got the factors we picked. 1 in the x, because the x has to roll with. And then you got 6 in the x, because the x has to roll with. Then we're going to put c. C was just 6 here. Now, this is where all that factoring out the GCF we had comes into play. Okay, we've done enough examples where it should get you. If not, just go ahead and list it out. So if I look at this column right here, and I say, hey, what do these things have in common? Well, I know they have a 1 and an x in common, so I know I can take out 1x. If I look at this column and say, what do these two things have in common? Notice there's not an x here, so they don't have an x in common, but they do have a 6 in common. Okay, and everything is positive, so I'm going to put a plus sign. Then I look at the row and say, what does 1x and 6x have in common? Well, again, they have 1x that's going to be in common. So that's our greatest common factor. So as we're doing the box, we're looking to factor out the greatest common factor. Then I do the same thing down here. Well, I got 1 and 6. Well, the only thing they have in common is 1. So my factored answer, okay, I'm looking for two things that can multiply to get me back to where I was at. Well, the two things that can do that are x plus 1, which is what was on this side, and then x plus 6. That is how you factor using the box method. We can do the same thing in the next example. The process never changes. You're going to list your A, B, and the C. So A is equal to 1, B is equal to 7, and then C is going to be equal to 12. Then I want to list CA, which is equal to 1 times 12, okay, which is just 12 in this case. Then I want the factors of 12, add up to equal 7. We get 1 and 12, 2 and 6, 3 and 4 are my factors of 12. Which one of those pairings can add up to equal 7? Well, you get 3 and 4. So now I just fill in my box. Ax squared goes here, so I'm going to do 1x squared. Then you get 3x here and 4x here. Down here, I'm going to do 12. So now I just need to factor out the GCFs. So I go ahead and ask myself, what is this column? What does 1 and 3 have in common? Well, the only thing they have in common is 1. And then they have a x in common. 4 and 12, they have a 4 in common, but no x's. 1 and 4, we just got a 1x in common. And 3 and 12 have a 3 in common. So my final factored answer is going to be x plus 4, x plus 3. Doesn't matter what order they're in, because it's multiplication. They can be in any order that you see fit for them to be, okay? They can be the other way around, all right? So just make sure you're factoring out the correct GCFs. That is the box method. Right now, it's super easy because our A is equal to 1. And if you notice, we really want, when A is equal to 1, we really don't need the box because I have my two factors right here. Let's do it.